And now we go to our keynote talks. It truly is a privilege today to have Dr. Vincent Tang to give us the first keynote talk. We'll have a second keynote talk as well. Dr. Vincent Tang is the Deputy Director of the ARPA-I organization. Many of you may not have heard of ARPA-I, but how many of you have heard of DARPA? The Defense Advanced Research Program Agency. It really has developed next generation technologies and have really transformed innovation in this country through the new models, innovative models they've put together. I've been following DARPA. There's books written about DARPA and so forth, and they've really transformed technologies in the U.S. Now, the Department of Transportation decided they're going to have their own DARPA. They call it ARPA-I, the Advanced Research Program Agency. For I stands for infrastructure, and it's a great pleasure today to have Dr. Vincent Tang, who's the Deputy Director, really first Deputy Director of the ARPA-I. And he's currently also has the duties of the director to establish the agency. So this is really groundbreaking work for transportation that's happening in Washington, D.C. Dr. Tang was most recently the principal deputy director of the National Ignition Facility and Photon Science Directorate at the Lawrence Livermore National Laboratory. He was part of the senior management team supporting efforts to produce transformational capabilities for DOE's at Department of Energy's National Nuclear Security Administration, including the historic achievement fusion ignition on the NIF for stockpile stewardship. This is a major program that you could read about. Prior to working at Lawrence Livermore, Vincent was a program manager at DARPA. So he actually has roots at DARPA, knows how DARPA works, and that's why he was asked to come over and really start a DARPA version for transportation infrastructure. So he created and led the agency's counterweapons mass destruction initiatives at DARPA when he was out there. He's Sigma Plus programs, developing and operationalizing large sensor networks with numerous interagency and state partners. So he's no stranger to bringing a lot of people together to solve very, very tough problems. He served on multiple national organizations, including DoD's Defense Science Board, and has been recognized with multiple awards, including DARPA's Program Manager of the Year Award and its Superior Public Service Medal. Now, that's a really big deal. So I'd like to give him a hand for that. So it's truly a big pleasure to have Dr. Vincent Tang here at the University of Maine today. Dr. Tang, please.
Morning, folks. So glad to be able to come today and tell you a bit about ARPA-I and efforts we are starting. With me today is also Kelley Severns, who is the program director for XBridge, which is our largest program, looking to deliver bridges with technologies for bridges that can allow us to deliver bridges at half the cost, half the time, making them last twice as long. And really glad to have Kelley on board to serve as the program director. With me today also is Sophia Chen, who's a AAAS fellow and also a technical advisor on XBridge. So we're all here to tell you about what we're doing, but also to talk to you and learn. Sorry, the slides are jumping a little bit. We're here to tell you about ARPA-I, XBridge, but also to learn about what you're all doing and figuring out the collaborations that we can put together so that we can be successful at transforming the transportation infrastructure of this country. All right, so I'm gonna spend about maybe 15 minutes or so telling you about ARPA-I, and then I'll transition over to Kelley, who will tell you about the XBridge program. So let me give you the bottom line up front. So why ARPA-I? What problems are we trying to address? And it's really about developing breakthrough technologies and innovation to address 4 long-term challenges in the transportation sector. First, we want to develop breakthrough technologies that can lower the cost of infrastructure. And that's everything from planning to construction to operations. And as many of you might know, those costs have been escalating for a long time now, and productivity in the sector has actually been decreasing at the same time. So it's a big problem. Of course, we also want to make that infrastructure much safer. 40,000 Americans die every year on our roads and highways, and that's simply unacceptable. At the same time, we're also spending over $1 billion a year, right, repairing our roads and bridges due to natural disasters, et cetera. And we need to make that infrastructure also more resilient to those threats, as well as both physical threats, as well as cyber threats. And then an overarching theme of ARPA-I is to also help develop those breakthrough technologies so that the US can be the global leader in transportation technologies. And of course, transportation and infrastructure, these technologies and our overall foundations and infrastructure here, serves as essentially a booster and foundation of our overall prosperity. So I think it's really, everything that we do in this room is really important to ensure that Americans have what they need to move efficiently and for our goods to move efficiently and for our economy to be prosperous. All right, so those problems have been, as I mentioned, like long-term challenges. What are we really doing that's different this time, right? What are we bringing to the table? And as Habib noted, right, I think the main innovation here is really bringing over that DARPA model innovation over to the transportation sector. And I saw that, many of you are familiar with DARPA. For those of you who are not, the Defense Advanced Research Projects Agency was started in 1958, actually by Eisenhower, a couple of years after the Highways Act. And it was in response to Sputnik. So Sputnik was a huge technological surprise, a strategic technological surprise. And the mission of DARPA was to make sure that type of surprise never happened again, and that we would create some of our own surprises. And as many of you are aware, DARPA over the last 60 plus years have been exceptionally successful in that mission, and also creating technologies that form many of the foundations of modern life. So of course, the internet itself is probably the biggest thing that came out of DARPA, but also, of course, stealth fighters and things like miniature GPS closer to the transportation sector here. And of course, the grand challenge and the odds really laid the foundation for self-driving and autonomous vehicles. 10 years ago, DARPA also made foundational investments in mRNA technology, which formed the basis for Operation Warp Speed and the vaccines that we were able to develop very quickly. If you're interested in learning more about DARPA innovation, there's a nice timeline. This is a slightly older version, but you can find it on the web. But again, if you look through that timeline and all the thousands of programs, these are sort of the greatest hits, right? Everything from Saturn V to the worldwide nuclear detonation detection, the internet, the stealth fighter, as I mentioned, miniature GPS, UAVs, Siri itself came out of a DARPA program, self-driving cars, hypersonics, that's just naming a few, autonomous ships. So, one thing you might ask is, well, okay, why should I listen to you to tell me how to, how to set up a DARPA or how DARPA works? And as B mentioned, if I had the fortune to work at DARPA for 6 years and to actually make this timeline, which is what every program manager wants to do. So really fortunate to have been able to lead some great teams to develop some region-wide counter WMD capabilities, working with state and locals and many partners, and actually getting these nascent technologies from very low TRL to actually operations over that 6-year period. So I'm a very strong believer in the DARPA model. I know it works, and I know that system allows us to take very nascent ideas that could be real breakthroughs and actually get it to operation in an accelerated time frame. So I'm very excited to have the opportunity to set up an ARPA-I for transportation. And of course, ultimately it's about this, right? ARPA-I, we're looking to accelerate the development of transformative transportation technologies that again decreases costs, increase safety, enhances resilience, and makes us more globally competitive. Now, let me tell you a little bit about how we actually do this. And DARPAs and ARPAs, and for those of you who work with them, you kind of know they're quite different organizations within the overall R&D ecosystem. And to be clear, DARPAs and ARPAs aren't everything, right? For a healthy ecosystem, R&D ecosystem, you need a broad range, but DARPA and ARPAs are a key part of a good R&D ecosystem. So DARPAs and ARPAs, some of the differentiation here is that ultimately, despite the fact that we are looking sometimes at very nascent ideas, it is ultimately agencies that are very problem focused. So for example, those long-term challenges I mentioned, we break those challenges down into problems that we set up programs to solve, right? And those problems could be really challenging, really hard. And the singular kind of unit of work at DARPA is really the program directors and program managers and actively manage metric-driven programs. So programs are 3 to 5 years. They're set up in a rigorous way in terms of how you gauge success, et cetera, so that you know if you're trying to look at a nascent idea that could have a large breakthrough, you can very rapidly figure out, okay, is there something here or not? If there is, scale it up, get it to prototype, transition it. If not, move and pivot to the next best idea. And the way we do this, we don't have research labs. We are looking for the best private and public sector teams to put together for any one particular problem. And we have a very nimble organizational structure to do that, and we have lots of unique authorities relative to statutory authorities, relative to other R&D organizations that let us execute this model. So think of us a little bit like the VC for the government. It's a little bit more along those lines. And so we have statutory authorities to use any number of contractual mechanisms and prizes, et cetera, to put together those teams and to run those programs. And we have unique hiring authorities that allow us to bring in program directors for 3 to 5 year stint, right? To essentially solve some of the hardest problems for their communities. And so from that point of view, that does allow us, if we execute the model properly, to act quickly and decisively to develop and transition into transformational technologies. Again, when you think of a DARPA program, transition and operationalization is thought about from day one, even for very nascent ideas, right? You want to figure out, okay, if this is successful, how do we actually get it beyond the technology demonstration? How do we actually get it into the system and transition it? All right, and one other way we think about these programs is through the Highmar catechisms. Some of you might be familiar with this. Highmar was a very famous DARPA director back in the 70s, and he formulated these questions, which every program manager had to answer for their program to be approved and ultimately to be successful, I think. Now, these are pretty basic questions, right, about an R&D project or program. What are you trying to do? How's it done today? What's the limits of current practice? What's really new in your approach? Why is it different this time? Why do you think you'll be successful? And if you're successful, who cares? Like, what's the real level of impact? And then, of course, your basic, what does the plan look like? What are the risks? What's the cost? What are the metrics and midterm exams? To answer these questions rigorously, quantitatively, is actually not easy. But if you can do this, you've got a reasonably good framing for a program. All right, so I went through that pretty quickly. I think maybe one other thing I'll note is that this time limit for both programs and for program directors and managers is really important, because you step into DARPA and it's and you go, okay, wow, this place invented the internet. What am I going to do? It's going to be relevant, and you're provided with a huge amount of support to change your community, to change the world, right, for the better. At the same time, you look at a clock. You got 3 to 5 years to do it. So everybody is very motivated to make it all work and to work with the external partners and collaborators to get this to the finish line, whatever they're trying to do. And so from that point of view, that is the culture that we also want to bring over to ARPA-I. And I think you'll see from programs like XBridge and what we're trying to develop there, we're bringing some of that model and spirit to the transportation sector. And I'm very excited about that. So now let me tell you a little bit about how we're thinking about the strategic areas that we want to make investments in as we're ramping up this nascent agency. So we think of it in 3 areas. We call them knowledge, construction, and optimization. You can think of this as sort of also know, build, and run. And essentially knowledge is, let me step through each of them, and then XBridge on the construction side will go into much more detail with Kelley. So knowledge is really knowing everything you need to know about your infrastructure, so you can know the problems of today, but also predict the problems of the future. And that's things like digital twins over very wide areas, cost effective, cost practical, right, digital twins, so that you can, for example, know which roadways are dangerous and take care of them before, they kill someone. So you can never have to, break a pipe when you're, digging into the ground, right? At the same time, if you have digital twins of your entire regions, you can also plot dynamically evacuation routes, et cetera. So there's a huge amount of potential in digital twins. And we have a seedling effort called Insights that I'll tell you just a little bit more about in a second here. looking at that and leveraging some actually unique DoD technologies. So one of the things we're also trying to do on ARPA-I is to leverage the breakthroughs that DARPA and our sister agencies are developing, right, and have made, and leverage them for transportation infrastructure. Now, of course, and I know many of you, working on materials or composites here, right? There will be applications, I think, across the board. So those are good opportunities. Now, one of the challenges for us is cost in this sector is really important, right? So leveraging a breakthrough technology, part of our challenge will be, okay, that's all great. How do we actually make it cost effective and cost practical enough so that a IOO could sustain and use it? And digital twins is exactly that. We could do that right now, right? If we put a ton of money into it, but it's not something that's sustainable given the ecosystem. So how do we develop technologies that are that can allow you to build wide area digital twins, but also in a cost practical way? And so one of the things we're leveraging is actually, yeah, you can play that for me, thank you. Some very unique LiDAR technology that the DoD has developed over years. And this is one of the most sensitive, if not the most sensitive LiDAR technology in the world right now. And this is literally a model of Boston that was built from that platform over 5 minutes of aerial coverage. That's it. They flew over Boston for 5 minutes and they were able to build this whole model. So this, from a technology point of view at least, says, okay, we can do very wide areas very quickly here with that type of system. Now, can we build on that technology and get it to a point that's cost practical? There's a corresponding discussion with AI on how to analyze that data, and that's what we're looking at too. So we'll be testing out some of those hypotheses under that seedling. Under optimization, optimization is really about optimizing the systems of systems, that is our transportation infrastructure, and that's leveraging connectivity and autonomy to do it. And so think about large scale traffic management over entire cities, doing it in order to reduce congestion, but also increase safety. Think about work that we can do to enable autonomous vehicle ecosystem as well as advanced air mobility. So think about air traffic control for drones and eVTOLs, right? That's going to be very different than our current air traffic control system. We're also working with DARPA, leveraging cybersecurity tools that they've developed over the transportation sector. So if folks are interested in that, please come talk to me. It's a really nice growing collaboration. And then finally, of course, construction, which is everything about advanced construction systems, but also about advanced materials. So XBridge is our biggest program and our first program, and it's in this space where we're again looking to develop technologies that can deliver bridges in half the time at half the cost while making the last twice as long. And really great that we've been able to partner with the University of Maine as well as Maine DOT and other industrial partners here in order to make this program happen. So now let me turn it over to Kelley, who will tell you a lot more about XBridge.
I'll go ahead and do a quick introduction about Kelley. It's a great pleasure for Kelley now to be the program manager for the XBridge program. Kelley Stevens has worked as a civil engineer for over 25 years in the bridge and transportation industry. So she's been out there for a long time, designing bridges, building bridges, working in different agencies. I'll give you an example of something she's done. Her initial experience was with the Kentucky Transportation Cabinet for 10 years. She then moved from the Kentucky Transportation Cabinet to AASHTO, the American Association of State Highway Transportation Officials, where she worked as a program manager for bridges and structures and hydrology and hydraulics for the next 10 years. So she's no stranger to AASHTO and how AASHTO works. Within AASHTO, she worked to influence transportation policy as it applies to bridge design, construction, inspection, and preservation, as well as oversee relevant changes to federally mandated codes and specifications and promote needed research. So if you're going to figure out how to go out there and get some new technology into AASHTO, you talk to Kelley. So she's been out there doing that for a long time. We plan to do that with her and work with you all as an industry to bring new technologies into the AASHTO code. As an independent contractor, Kelley also was able to perform research through transportation funding arms and partner with several different universities. She spent 2 years working with CH2M, which is now Jacobs, an international engineering firm, where she was lead for national marketing and strategic planning for the complex structures division all across North America. Kelley also spent 3 years working with WSP USA as the Assistant VP for Bridge Research. At WSP, she was a project manager, she was a principal investigator, a business development lead for the Complex Bridge Division. She also spent several years in the Louis Berger now Verser Infrastructure Asset Management Division, where she was a senior business development lead as well. Finally, she's in her current position, she's the program director for the ARPA-I X-Bridge program, which stands for the Exceptional Bridges Through Innovative Design and Groundbreaking Engineering. Please help me welcome Kelley Severns. Take care.
Thank you, Habib, and thanks to Vincent for that great overview of ARPA-I. I'm really glad to be here today. I really appreciate TIDC giving me the opportunity to be a keynote speaker this morning. And I'm really grateful to the University of Maine for granting me an honorary doctorate degree today. So I'm just joking, but you notice in the program, I'm listed as Dr. Kelley Severns. Unfortunately, I did not finish that dissertation. However, what I do have, I don't have the PhD, but I do have almost 30 years of experience working almost entirely in the bridge industry. And as Habib said, I was able to spend over a decade working with ASHO as the program manager for bridges and structures. During that time, I really had an opportunity to listen to the bridge owners. You know, I worked closely with the Committee on Bridges and Structures, and I was able to really hear a lot of the challenges that the bridge owners were having, keeping their bridges safe, keeping them in a state of good repair with the resources that they were provided, which sometimes were limited. And so that's why I'm really excited to be a part of ARPA-I as the program director for X-Bridge, which, as you've heard, is the Exceptional Bridges Through Innovative Design and Groundbreaking Engineering program. It's an opportunity to work with the University of Maine to move these advanced composite technologies that Habib has told us a lot about this morning in the bridge industry forward and focus our research in a really fast-paced environment. And we're going to implement real change in the industry. These are not new numbers, right? We've all been looking at these numbers for as many years as I can remember in the bridge industry. You know, we have over 600,000 bridges in the country that are many of them in need of significant repair and replacement. And it's going to cost us, you know, over $100 billion to be able to do the things that need to be done. In the US alone, our corrosion costs are over $8 billion annually, according to Federal Highways. So ARPA-I really has a significant opportunity here. You know, this is a big problem, and we have an opportunity to use advanced composites technologies to address some of these challenges. So the industry has been looking for ways to really do more cost-efficient designs for years, things like LRFD bridge design implementation or designing for a 100-year service life. We have been working on those efforts. We've also been working for a very long time on how to cut down on our construction time, how to get in, get out and stay out, right? There are a lot of great new technologies in accelerated bridge construction out there. And also we have spent a lot of research looking for new materials that deteriorate less quickly, are more resilient, and ways to make good decisions about preserving our infrastructure. What maintenance activities do we need to do? But still, we have the issues, right? We still have these challenges and we still have a need for change. So that's why we have X-Bridge. So X-Bridge aims to address those concerns, and we're going to leverage advanced composites and advanced system engineering to deliver bridges at, as Vincent said, half the cost in half the time with twice the lifespan. That is our goal. It might be ambitious, but that's part of the ARPA spirit, right? So we're really happy to be working with Maine DOT, and this part of this will be to build a full-scale prototype bridge within the next few years. And we want to be able to engage and enable bridge owners to have these solutions to build these safer, affordable, and reliable bridges. And we think we're ready for a full corrosion-free bridge, ready to implement that technology. So I'm going to show you a few slides over the next few slides, some of the aspects of our vision for this X bridge. I think you may have seen some of these technologies before. I think you saw some of them today. Habib's already talked a little bit about some of them. But our approach is to use all of these innovations in addition to improved and optimized manufacturing techniques to really reach these goals. So this might look like a typical bridge cross-section to you, but there are many innovations throughout. We're looking here at a basalt fiber reinforced deck, which allows for a corrosion-free option, as well as reducing the need for a larger amount of rebar. Continuing with that corrosion-free material theme, we're using FRP rebar as well in this deck. At the same time, underneath the deck, we're going to investigate the advantages of arching action to minimize overall concrete and reduce the cost further. So the arching action is achieved through these stay-in-place FRP arching deck forms. Continuing with the corrosion-free superstructure, X-Bridge will investigate several types of FRP composite girders. This might look a little bit familiar. You saw the girders earlier in Habib's pictures. We're going to be looking at optimal manufacturing techniques and material properties and also geometric design. So this will result in a system engineered, corrosion-free, FRP composite, cost-efficient superstructure. So this is a concept that we believe could really change the future of bridge design, as well as the manufacturing and construction of composites industry. So much of this X-Bridge system you just saw, like I said, isn't necessarily new. We've been talking about investigating and developing prototypes of these type of innovations for decades. So why are we not seeing the use of composites more throughout the bridge industry? And we have some ideas about that. You know, what are the challenges with advanced composites implementation? So we believe the number one challenge is that it's just cost prohibitive right now. Advanced composite use in bridges is cost prohibitive, especially in the current initial cost compared to traditional construction, traditional materials. So there's also limited experience with composites in the bridge industry overall, and often inadequate guidelines and specifications for this material and being used in bridges and infrastructure. So the X-Bridge project believes that bringing down that initial cost of the advanced composites is really the catalyst for acceptance in the community. So X-Bridge is going to work to bring down those costs through an integrated approach. Systems engineering, as we discussed before, will lower the initial cost of the advanced composite girders through a full interconnected program that goes from testing to prototype and includes optimizing materials, design, and construction processes. To add to that, we'll be looking at efficient, scalable manufacturing processes using innovative new materials and techniques to reduce costs through less labor. And we'll partner with the Maine DOT throughout the project, and then we will be working to build a 75-foot bridge prototype in Maine. And this will help us determine the needs of the bridge owners. We really want to listen, hear how we can work with the DOTs, and this will give us that experience and that feedback that we need to be able to move this forward. And it'll also give an example to other bridge owners who want to use these technologies in the future. And lastly, we'll use our research results and lessons learned from our partnership with Maine DOT and other industry leaders to develop specifications and guidelines to help the technology transfer, making this composites usable for all bridge owners. We're looking forward to working with other state DOTs on this as well throughout the process. So please talk to me more. We need all the input we can get here. So just to give a little bit more detail on the goals of reducing manufacturing costs and defining optimal materials. We'll be looking at ways to automate processes that are currently labor intensive. For instance, automation of fabric placement. And in addition, we will investigate continuous production methods, determining if pultrusion is a viable option for bridge girders, for manufacturing bridge girders. And we'll investigate a variety of material and manufacturing options for thermoset, thermoplastic processes, such as thermoplastic rebar is one area we'll be looking at. And we'll also be looking at basalt as a novel fiber for use in the composites. Lastly, we're going to develop, University of Maine will be doing accelerated testing and at-scale testing and of the bridge components and the materials to prepare the way for the guideline and the specification development. In addition to looking at the cost savings with manufacturing, we've also done the work to determine if these solutions are actually going to result in cost savings throughout the bridge life cycle. In our initial life cycle cost analysis, we found that if we're successful, we can expect to achieve a completely composite bridge superstructure with initial costs that are 15% less than that of a conventional bridge materials. And when we take into the account an expected 150-year service lifespan of these composite bridges with minimal maintenance because of the composites, and less need for deck repairs, less need for deck replacements, less need for maintenance activities in general, then the overall life cycle costs become less than half of that of a conventional bridge. So finally, we're already working, as I said before, with Maine DOT, and we're really grateful to have that opportunity. And we will be working with them to select a site for the 75-foot bridge prototype with a goal to begin construction on this prototype bridge within the next 3 years. And the prototype will provide an example for bridge owners that are interested in implementing these type of composite girders. One of the things that I was often asked at AASHTO was, what are the other states doing? And so that's often something that everyone wants to know. Are they doing this? Is it successful? How is it working out for you? So that's one of the things that we'll be able to do as we build this bridge with Maine DOT. In parallel with that prototype design and construction, we're going to work to develop those needed specifications and guidelines with organizations like AASHTO. I know University of Maine has worked with them, worked on these type of guidelines before, and we'll be working with them to develop the needed guideline specifications so that everyone can use this technology. So the real success is going to be measured by the community acceptance. And by the implementation of these corrosion-free full composite superstructures. So we want to hear from you. We are here to listen. You, I think, are going to be the ones that are going to move this forward. You are going to be the catalyst for us to keep moving forward and get acceptance. And so be the catalyst. That's why we're all together here today, I think, to really get excited about these opportunities and move this forward. So please come talk to me. Let's talk about what your thoughts are about X-Bridge, how we can all work together. We want to hear from you. I'm here, today and tomorrow. And also you can email me. And so I'm really looking forward to working with the University of Maine, working with all of you, working with ARPA, and being really happy to have this program director position. So thank you guys very much. I look forward to talking to you.